Hello everyone, how are you all doing? In this discussion, we will learn to implement hub and spoke VNet architecture in Azure Cloud from scratch. We will set up everything, including virtual networks, virtual machines, anything that is needed for this demonstration. So, what is hub and spoke model? You have a hub, which is a central point, and you have spokes connected to that hub. In case of our hub and spoke model using virtual networks, we have a hub virtual network, which in our case is deployed in East US, and let us call it VNet Hub East US. We will have two spokes. One VNet Spoke 1 East US, which is deployed in East US region. To demonstrate global virtual network peering, we will have one Spoke 2, which is deployed in Canada Central region. Why do we need a hub and spoke VNet architecture in Azure? A hub and spoke VNet architecture in Azure centralizes shared services like firewalls, VPN, or express route gateways, DNS, etc. in the hub, while isolating workloads in spoke VNets. This improves security, governance, and cost efficiency by enforcing consistent controls and reducing duplicated infrastructure. It also enhances stability and manageability as new workloads can be added as spokes without impacting existing networks. We will see the example of deploying a VPN gateway into our hub and connecting to our spokes through the hub in a future follow-up session. Before we proceed, I am Hartin Jacob Kanigatotu. And if you need to know more about me, you can learn more about me by going to my LinkedIn profile, which is linkedin.com/in/Hartin, or you can go to codingarchitect.ca/contact and find my LinkedIn profile URL and also my WhatsApp or other contact information. So do check back here because I might change my contact information in future and I will try to update it here. Let us get started with implementing hub and spoke virtual network architecture within Azure Cloud. So first you need to log into portal.azure.com. Then we need to create three virtual networks and later three virtual machines in each of these virtual networks to demonstrate the hub and spoke implementation that we are going to make. After making sure that there is no connection between these virtual networks by trying to connect from these virtual machines, we will implement peering. We will demonstrate that the connections are going to be successful. As discussed in the introduction, we will need three virtual networks and three virtual machines. First, we will create the hub virtual network. You need to start by selecting your subscription and resource group. Region will be East US for the hub. A meaningful name for the hub. In our case, it is VNet Hub East US. Click on Next. We do not need Azure Bastion for this demo in case if you are using RDP directly from your machine. The virtual machines that we create will support it. I am just enabling and using Bastion since it is easy to demonstrate everything from a single window with the Bastion. So rest of the things I will leave as is. I will give the IP address range for this VNet as 10.0.0.0/16. Rest of the things we can leave as defaults and then click on create. As the deployment is in progress, let us go and create our second virtual network. So this will be the spoke which is in East US. First you have to select our subscription, resource group and a meaningful name, which in our case will be VNet Spoke 1 East US. As I mentioned earlier, I'll be selecting Bastion for easy demonstration. You don't have to do it if you are planning to connect over RDP from your local machine. As you can see, we get a warning that this address prefix overlaps with the virtual network hub. And if you intend to peer these virtual networks, change the address space. This is a requirement for peering. The address spaces of two networks that are going to be peered should not overlap with each other. For the Spock 1, we will give the IP address as 10.1.0.0/16. Rest of the things we will leave as defaults. We will click on create. The deployment is in progress and we will create our third virtual network. Select your subscription and resource group. Select the region as Canada Central to demonstrate global virtual network peering. This is just a fancy term for telling that we are peering across regions. We will give a meaningful name, which is VNet spoke to Can Central in our case. I'll select the Bastion option as we discussed. You can actually do this later also from either the virtual networks page or even the VMs page. Rest of the things we will leave as defaults. For Spoke 2, we will give the IP address range as 10.2.0.0/16. Click on next. Once your review is passed, click on create. I'll post the video during the deployment to save time and then we can continue once it is done. As the virtual network deployment is complete, we will proceed with deploying our virtual machines. We will need to select subscription and resource group. This is for the hub VNet. We will call it as VM Hub East US. Region is East US. Availability we will set as no infrastructure redundancy required since we are not focusing on availability here. Image we will select as Windows Server 2025 Data Center Azure Edition. Rest of the things standard defaults. Give a username and password to log into your virtual machine later. Inbound port rules we will allow RDP port so that we can log into this VM from internet using RDP if needed. But in real world scenarios, you may be using a Bastion host or a jump server, maybe the one that comes from Azure as a service or a custom jump host that you set up. The disk page, we can select a standard SSD as we really don't need a premium SSD for this lab. We will leave other things as is. In the networking tab, we can select our hub VNet. And for the public IP, you may create a public IP if you are planning to log into the VM from internet over RDP. If you are only using Bastion, then this is not needed. Delete public IP and NIC when VM is deleted. Load balancing we will not look into right now, but we will look into it in a future discussion. On the management tab, we will leave everything as defaults. On the monitoring tab, we will leave everything as defaults. On the advanced tab, we will leave everything as defaults. Tags, if you want, you can add. Review and create. Once the validation is passed, you can click on create. The deployment is in progress. We can now go and create our second VM. Create virtual machine, select subscription and resource group. So since this is for VNet Spoke 1, we will name the VM as VM Spoke 1 East US. Region is East US. We will select options as we selected for the first VM. Remember to select standard SSD as we don't need premium SSD. On the networking tab, we will select Spoke 1 VNet. So here, as you can see, we will not be able to see our Spoke 2 since it is in a different region. So rest of the things select as we did for VM Hub East US. Click on create. The deployment is in progress and we can go and deploy our third VM. Select our resource group and subscription. Give a meaningful name. Since we will be deploying this into VNet Spoke 2, we will name this as VM Spoke 2 CAN Central. Select region as CAN Central. Rest of the options same as how we did for our other two VMs. Here under the networking section, we select our Spoke 2 CAN Central VNet. Rest of the options same. Remember to select delete the public API and then IC when VM is deleted whenever you are doing this as part of a lab exercise. Other tabs we will leave as defaults like we did for other two VMs. Finally, click on create. I will wait until all the deployments are over. I'll pause the recording until then and then we can continue. The VM deployment is also completed. Now we can go ahead with virtual network peering. Before proceeding with peering, we will first verify that there is currently no connectivity between these virtual machines that are deployed into three different virtual networks. We can connect to these virtual machines either using RDP from our local machines or using a jump host or bastion host that are either created by us or the managed bastion service provided by Azure. In our case, we have already set up the bastion host as well as the RDP setup so that based on what you followed, you can use that. In my case, I will be using Bastion since it is easy to demonstrate in a single screen. In your case, you may use RDP, and if you are using RDP, you can go to connect and then you can go to more ways to connect and then you can click on connect via RDP. You'll get all the RDP information. You can download the RDP file and then you can connect. Let me connect using Bastion. I'll do the same for other two virtual machines also. So this is my hub virtual machine. This is my Spoke 1 virtual machine. And this is my Spoke 2 virtual machine. I'll also start PowerShell. From hub, I will try to connect to my spokes. So I'll first try to connect to Spoke 1. Do you know why I simply typed 10.1.0.4? That is because within the subnet, 5 IP addresses are reserved. So which are those 5? The first 4, which is 10.1.0.0, 0.1, 0.2 and 0.3, and also the last one. So the first IP address is 10.1.0.4. Similarly, for the spoke 2, it will be 10.2.0.4. As you can see, the connection has failed from the hub to both the spokes. Let us quickly try connecting from the spokes to the hub. The command is similar. So here we will need to use the IP address of the virtual machine deployed on the hub. And we can do the same from spoke 2 also. We can try to connect to hub VM. So from spoke 1, the connection has failed. From spoke 2 also, the connection has failed. So now let us go and set up virtual network peering from hub to both the spokes. So first let us go to virtual networks. Let us go to hub. Let us go to settings, peerings, and add peering. When you add peering, you can add both the local and remote peering from the same place. Later, if you want to configure, you have to go to the respective places, either to the hub or either to the spoke. So here, first we can create for spoke 1. So here, remote is spoke 1, right? VNet spoke 1 is to yours to VNet hub is to yours. And you can select the spoke 1 virtual network. Under remote virtual network peering settings, there are few different settings available, like allow VNet spoke 1 ESTOs to access VNet hub ESTOs, allow VNet spoke 1 ESTOs to receive forwarded traffic from VNet hub ESTOs, allow gateway or route server in VNet spoke 1 to forward traffic to VNet hub ESTOs, enable VNet spoke 1 ESTOs to use VNet hub ESTOs remote gateway or route server. We will explore these options one by one in future discussions. For now, let us just allow spoke 1 ESTOs to access hub ESTOs. Within the local virtual network summary, we can provide the peering link name as VNet hub ESTOs to VNet spoke 1 ESTOs. We can select allow VNet hub ESTOs to access spoke 1 ESTOs. So this settings under the remote allows spoke 1 to connect to hub, and in the local peering we are allowing hub to connect to spoke. Click on add. So we are actually creating two peerings here from same screen. Peering is done. As you can see, even though we created two peerings, we need hub to spoke 1 and spoke 1 to hub. We can only see hub to spoke 1 within the hub virtual network page. If you go to the spoke 1, if you go to peerings, there we can see a spoke 1 to hub peering link. Similarly, we can create for spoke 2 also. We can come here and then we can create. We may also create it from spoke 2 instead of from hub. So either of the two places we can create. We will add the second peering for spoke 2 with hub also from here. In the remote peering link name, what is the remote peering here? It is spoke 2, right? So the remote peering link name will be spoke 2 to hub, and we can select the spoke 2 virtual network. We need to select the option allow spoke 2 to access hub. Similarly, under local virtual network summary, here what is the local? So local, it is hub, right? So we can give the name as VNet hub east US to VNet spoke to CAN central. Select the option allow VNet hub east US to access spoke to. So hub to spoke to is also done now. If we go to spoke to and if we go to peerings, then you can see spoke to hub link. Now that peering is done, let us go back to our virtual machine and try to run the same commands. First, we will try to connect to spoke 1 from hub. The connection is successful now. We will also try to connect to spoke 2 from hub. That is also successful now. We can try to connect to hub from spoke 1, which is successful now. We can also try to connect to hub from spoke 2. That is also successful now. However, if we try to connect to spoke 2 from spoke 1, that will fail. Similarly, if we try to connect to spoke 1 from spoke 2, that will also fail. This is because spoke 1 is connected to hub and spoke 2 is also connected to hub. But spoke 1 and spoke 2 do not have a direct link. Virtual network appearing within Azure Cloud is not transitive. That means if a spoke 1 is connected to hub and hub is connected to spoke 2, By default, Spoke 1 and Spoke 2 cannot talk to each other. To do that, we need to do some changes with respect to routing, and we also need to deploy a appliance within the hub that will forward these requests. Plus, we will need to make some changes to the virtual network peering to allow these forwarded traffic as well. We may also create a VPN gateway on top of our hub and spoke VNet architecture and connect from our local machine to our hub and the spokes, making use of gateway transit configuration within our peering links. We will see that also in a future session. Bye bye for now and see you all in next class.